So without further ado, let's get right into it here. Tonight's guest speaker is a geographer who recently retired from the leading provider of geographic information systems called GIS software. And he has witnessed total solar eclipses since 1991. And in 2009, while writing his book, Modeling Our World, he realized how advanced GIS technology could be applied to publish new eclipse maps of high precision and good cartographic quality. So after creating his first eclipse map for the total solar eclipse of July 22nd, 2009, he launched eclipsemaps.com in 2010 to showcase the new and historic eclipse maps. And recognizing the widespread public interest in August 21st, 2017, the big eclipse that year, he launched greatamericaneclipse.com on August 21st, 2014. And that was the talk of the town at the Saskatchewan Summer Star Party, as I was telling our guest speaker, because I was at that star party when the site launched, and everybody was talking about it because, that was the kind of 3-year marker toward the eclipse. And so he is a member of the International Astronomical Union Working Group on Solar Eclipses and is honored to have an asteroid named after him. And I just want to say to the members present here tonight, where's my asteroid? I'm waiting. Just a subtle hint there. So without further ado, please welcome Michael Zeiler. Yeah. Okay.
Thank you so much, Richard. And thank you to the Kalamazoo Astronomical Society for staging this wonderful eclipse series. It's the only astronomy club in the country that I'm aware of that's doing anything remotely like this for the eclipse. So kudos to Kalamazoo. And so I'd like to present the Kalamazoo Astronomical Society with 2 of the books that I've written on eclipses. And this one here is the field guide to the annular eclipse last fall and the coming April eclipse. So this has all the detail that you want to know about the eclipse. It's a field guide, which means it's designed to be used on the road. So if you're in an area where there may be patchy clouds and you need to skedaddle and get out of town, this is your guide, because this will show you detailed maps of where to go to get the best view. And then in the afternoon of April 8th, some of you might get the idea that you might want to see more total solar eclipses after you've seen your first this coming April 8th. And if you get smitten by the bug, then this is your vacation planner for the next 25 years. It's my vacation planner because most of my vacations are determined by where solar eclipses happen. And it's a wonderful hobby because you get to combine beautiful places on our planet with the most magnificent celestial sight. So these are for the Astronomy Club. And thank you so much to Richard Bell for being the ball of fire behind all of this. You're lucky to have him in your community. Okay, so I'm going to present a tour of the eclipse, and it's going to be in several parts. First of all, as Richard said, this is just a summary of my biography. I'm a professional cartographer, also eclipse chaser, and starting around 1909, I realized no one else was producing eclipse maps of high quality and precision, so I decided to step up and make them myself. I made them initially for a cruise that I was on in 2009. So I'll talk about this more in a little bit. I'll speak a little bit about how to create extremely precise eclipse maps. But the short answer, and the reason we're creating these precise maps is because we can. We have the data now. We have the laser altimeter data, first from the Japanese spacecraft called Kaguya, and then followed by the US NASA spacecraft called Lunar Reconnaissance Orbiter. That data, which became available for about a dozen years ago, for the first time made these extremely accurate eclipse maps possible. And later in the presentation, I've made a variety of different types of eclipse maps, and I'm going to show you a world premiere of a brand new type of eclipse map that no one besides myself and my wife have seen. So that'll be fun. So the topics we're going to be covering are flying with the moon's shadow, what's special about eclipses, the path of totality, venues to see totality. There's some very interesting places to see. What the impact of totality on our nation will be. Maps of special eclipse phenomena, as I just alluded to, you'll get a world premiere. And then I'll close with a survey of coming eclipses. And so we'll review that. Now, this is an animation that I made. It took a lot of time to make this. It took months to make this. And this shows the precise shadow of the moon crossing from Mazatlan, Mexico, all the way to Newfoundland. On the sides, you can see the local time and the duration of totality if you are in the center of the path, plus the speed of the moon's shadow. As this video goes on, keep an eye on that speed, because it turns out that the speed is slowest at where the eclipse is longest, and where the eclipse gets a little shorter as you go on, speed picks up. And it makes sense if you think about it and know a little geometry. The width of the path will also vary. It's a little over 120 miles at the beginning, but then you'll see it steadily getting a little bit shorter as the geometry of the moon's shadow diminishes as it crosses. Now, we just crossed Dallas, and we're reaching Arkansas, a great spot for the eclipse. You can see Little Rock is on the edge. While this is progressing, I want to point out that the moon's shadow is not a perfectly smooth oval, but it has these points in it. I call these inflection points. And we'll talk about that a little bit later. That actually turns out to be something very cool that you can see if you are at that inflection point. Now we're coming close to the area. For example, Wapakoneta is probably the closest destination in the center line from here. So many people from here will go to that region. And now we're coming to the Cleveland, Lake Erie. What a scenic spot this will be, Niagara Falls during the eclipse. Hopefully it's clear that day. And hopefully it's clear in many of these places. It may be a little bit of a challenge, but I'll speak briefly on what you can do to improve your odds of clear weather on eclipse day. And now we're about to leave the United States and the eclipse will finish its track through the Atlantic provinces of Canada. And here's Newfoundland. Now watch the speed. The speed is going very rapidly. And there's a reason for that. Okay, now I'm going to speak about what's so special about eclipse maps. I personally am beguiled by eclipse maps. I think they're really cool. And what's really cool is this is the first ever eclipse map that was produced in 1654. And I've made a modern map to compare against this, and this was remarkably accurate for the time. And so why do we take the effort to create an eclipse map? It's a lot of work. It's a lot of computation. It's only good for one day, a few hours in one day. So why do we bother? Because eclipse maps are treasure maps. They're your guide to the most beautiful celestial sight you'll ever see. It's such a special event that's worth making a map for a single event that lasts only a few hours. And we're going to be taking a tour of a lot of different types of eclipse maps. This here is the first eclipse map from the Americas. This eclipse map is from 1727. And there's a lot to say about this map. For the real geeks, I could speak an hour just on this map alone. But what's interesting, what this map was really used for back then, the treasure this map was seeking was longitude, because it turns out that an eclipse is a good way, if you record the eclipse accurately, it's a good way to determine your longitude in the New World. So that's why this map was constructed, so that people there knew roughly where the path was, and they could prepare themselves. And this is the path of total solar eclipse. Generally correct. What's interesting about maps in this day too is that our geographic understanding about eclipses is much better than our geographic understanding of continents at that time. That's an interesting thing. This is the first US eclipse map. This was produced in 1834, more than 100 years after the first Mexican eclipse map, which we just looked at. And here's a little bit of a detailed look at this eclipse map. It makes me wonder, why did it take the US 100 years longer than Mexico? I'm not sure. But that's a historical record. Beautiful map. And this map was also modified for another eclipse. Now we're going to take a tour through the path of total solar eclipses on April 8th. This map gives you an overview. The figures on the side show the maximum partial eclipse that you'll experience on eclipse day. But the real emphasis, the visual focus, is the path of totality. And so I made a color ramp that shows where the duration of totality will be longest, which is the yellow zone down in Mexico and Texas. But the duration is not too bad as you go further up. You can get a full 4 minutes of totality for quite a distance. Now, this is one of my most popular maps. And the beauty of this map is that it drives home that if you possibly can, don't watch the partial eclipse. Do whatever you can to get to the path of totality, and it's not very far from here. So you've got a good chance. And people love this, but this is so true. You'll still see something interesting when you're in the partial eclipse, but not like totality. This is an animation that I made with my friend Fred Espenak that shows the eclipse. And this is another one that shows the shadow creeping across the United States. This is another type of animation different from the flyover animation you saw earlier. But this shows how the shadow crosses the nation. Now, one thing you'll notice as the shadow progresses is that at the beginning in Texas, the shadow is relatively compact, but you're going to see it spread out as it moves along its path. And the reason why that oval shape becomes more elongated is because the eclipse ends at sunset in the North Atlantic, and over New England, it's already late afternoon. So the sun is lower, and if the sun is lower, then objects cast longer shadows when the sun is lower. Same thing with the moon's shadow during an eclipse. That's why the shadow becomes elongated. It moves faster, the speed is faster too. This is a map that I made. I made a series of maps for each region of the United States that gives you quite a bit of detail. So this map can be used again as navigation on eclipse day. One thing you'll notice too is there's a tiny bit of Michigan that's inside the path of totality. Now, sometimes in news stories, you'll hear that there are 13 states within the path. Well, that's not quite true. There's actually 15 states in the path, but 2 states just have a tiny corner. Michigan is one, and Tennessee is the other. Tennessee has a tiny corner in the path of totality. So there's 15 states within the path of totality. And this gives you a good overview of the eclipse. It tells you the times, the durations, how much partial eclipse. This has been a very popular map. Now I'm going to show you some maps from the field guide to the eclipses that I did with my friend Michael Bakich, who is retired senior editor from Astronomy magazine. This is the cover of the book. And so these are pages from our field guide that go into great detail. So you can determine pretty much down to the second if you are near the center of the eclipse path for how much duration you're going to reach. These are extremely accurate calculations. And the calculations that I make in collaboration with my friends Xavier Joubier and Fred Espenak, the calculations that I make take into account the rough edges of the moon. In the old days, 15 years ago, in the old days, eclipse mappers assumed that that the moon was perfectly round. And that's not an unreasonable assumption because it's pretty close. But if you look at the moon with binoculars, you can clearly see that the limb of the moon, the edge of the moon, is a bit rough. You can see some mountains and craters and valleys right on the edge. So using that data that became available about a dozen years ago from the Japanese and American spacecraft, we now have a very precise model of the moon's shape. And using that very precise model, and it gets even worse. because the moon isn't fixed, or it's not showing, it's showing the same face to us. It's tidally locked, but it's got a little bit of a wobble. And that wobble is called libration. And so we also have to take into account libration and how the moon's shape changes with each little wobble that it encounters. So there's quite a bit of computation that goes into this. But the end result now is that accounting for the moon's shape, we believe that we have less than, we are within 1 second precision of eclipse precision, of eclipse predictions. Before it was several seconds. Now it's less than 1 second. And we can also determine the edge path very accurately as well. Right now, we're scrolling through some of the pages in the field guide. And the information that you can get from these pages, this shows you the times of greatest eclipse. So this area here has greatest eclipse at 2:03 p.m. Central Daylight Time. That's how you would read that, in a duration of 3 minutes and 40 seconds. In this map, I intentionally don't give any information about partial eclipse, because if somebody is here, I don't want them to think that they've got 99% partial eclipse. So, because I've encountered people who believe if they have 99% partial eclipse, that's 99% of everything. 99% of a partial eclipse is 0% of a total eclipse. The difference literally is night and day. It literally is. It's the difference between a daylight, certainly a very dim daylight, but sudden darkness and an astonishing sight. It's a qualitative difference between the two. So I hope everyone in this room can drive at least what is it, 100 miles or so to Wapakoneta or that area. 100 miles or so, maybe 150. That's nothing compared to the glory of seeing a total solar eclipse. So I would encourage you all to make that trip. You'll probably get, I didn't look it up, but I'm guessing you probably have 96, 97% partial eclipse here, something like that. But again, it's a 0% total eclipse. So make that drive. Okay, now we're covering the Great Lakes. The duration of the eclipse is diminishing a bit. Now it's 3 minutes and 39 seconds is the maximum eclipse, but that's still a very healthy duration. What's interesting about this eclipse is that the duration is nearly twice as long as the 2017 eclipse. So it's a very good duration. I've seen longer eclipses, but this will be one of the longer ones I've seen. Typically, recent eclipses have been 1 or 2 minutes. The one in 2017 was 2 minutes and 40 seconds. Last April, if you can believe it, I traveled to Australia for a total solar eclipse less than 1 minute. I literally traveled all the way around the world, but it was worth it, let me tell you, because it was one of the most impressive eclipses, because we had a giant solar prominence embedded in the corona during eclipse, and that was magnificent. And all of us who went were thrilled for, even for less than 1 minute of totality, it's worth traveling to the ends of the earth. And now we're coming to the end of our eclipse path. Prince Edward Island would be an interesting place. I understand there's a very scenic lighthouse on the very tip. That will be a popular location if it's clear that day. And now we come to the very end, Newfoundland and the island of Newfoundland. And after Newfoundland, the eclipse will progress into the North Atlantic Ocean. It will come not too far from the British Isles, but not quite. The British Isles will see an interesting sight, though. They will see a sunset partial eclipse, which can be very dramatic. I've seen some very cool sunset eclipses. So that's what the people in the UK get. So these are the core maps in our field guide that relate to the 2024 path. As I said earlier, this is designed to be used on the chase. Okay, now we're going to visit some interesting places, some interesting twists to see the eclipse. Did you know that there are 5 NASA crewed spacecraft in museums inside the path of totality? Isn't that amazing? That's remarkable, including Wapakoneta, I think 2 Apollos, a Skylab, and 2 Geminis. So if you're going to any of these places or in around, that would be a great side visit to see. And probably all of these places will have great eclipse viewing events on eclipse days. So that's one little twist or wrinkle for finding a great place to see the eclipse. This is a really cool map. This is one of my favorite maps. How much sunshine, you can simulate sunshine on outer planets during a partial solar eclipse. So if you are here at maximum partial eclipse, you get the same sunlight as you would if you were standing on Mars. Here you're standing on Ceres, a dwarf planet in the asteroid belt. Here you're standing on Jupiter and then Saturn. And then these detailed maps show it get closer. Saturn, Uranus, Neptune, Pluto. So if you can't get to the eclipse, you can at least think, well, I got to Jupiter or something. Actually, that's probably roughly where Kalamazoo is, I would say, is roughly a Jupiter level brightness of sunshine. So, all right. And if you want to see the eclipse from Corona or Sun Valley or Shadowland or Moon, or best of all, Eclipse Island in Newfoundland, you've got choices. So these are not all, but well, these are all the key, and this is moon shadows. These are some of the key places that I found with eclipse-related names. So that could be a cool destination to go. All right. Now, another cool map. These are the national parks inside the eclipse path. Okay. A national park is a great place to see the eclipse because you're surrounded by natural beauty, and but also what's interesting about visiting national parks for the eclipse is generally they have dark night skies. And the eclipse, by definition, happens during the new moon, when there's no interference from the moon at night. So you can enjoy the eclipse during the day and the Milky Way at night. That's a good combination. Some people like to see the eclipse from a very high location. There have been some very interesting historical records of people who saw the shadow racing across the landscape from on top of Pikes Peak in 1878 and other eclipses. So this is a guide to some interesting places to see. In New England, actually, there's quite a few ski areas that may be running chairlifts So in upper Vermont or New Hampshire, you might be able to just take a chairlift up and see the shadow racing across a landscape if it's clear that day. These are planetariums inside the eclipse path. Of course, you don't want to be inside the planetarium, but the planetarium is going to be your local source of information for eclipse and maybe where you get your eclipse glasses, and they will certainly have programs going on. So this is a list of great places to go. In this area, it looks like University of Toledo, Bowling Green State Universities, Armstrong Air and Space Museum. That'll be a cool place to go. Stadiums and speedways. The people who like to be on a mountaintop will enjoy what I call a me-clipse. People in the stadium will enjoy a we-clipse. Okay, and it's a personal choice. It's an amazing experience to be in a stadium with thousands of other people, and totality comes. And that happened in 2017 in several venues. But it's not for everyone. But if that's what you would like, then this is for you. There's 2 Major League Baseball stadiums inside the path, and they both have home games that day. And I'm pretty sure that they both are going to arrange their schedule so that the game starts probably right after the eclipse or something. So that'll be an interesting choice or venue. Now, these are zoos in the path. Okay, and everyone's heard stories about the reactions of birds and bees and animals to an eclipse. Well, if you want to do some citizen science, go to one of these zoos. And looks like the closest one here is Toledo Zoological Gardens. Cleveland has a zoo, Indianapolis, and so forth. I would like the African Safari Wildlife Park. That might be the best one. Okay, now we're going to talk about the impact of the eclipse. And it's going to be a big deal. I made this very detailed calculation of estimating how many people will come to see the eclipse. And this is based on 2 assumptions: that people will drive the shortest path from their location to the center line of the eclipse. And the second assumption is that if you live near the eclipse, you are more likely to come to see the eclipse. So putting some numbers on that, this is the analysis that I came up with. So you can see how the drive patterns, if people drive the shortest path, they'll converge on these places, and the places with the larger circles are going to receive more people. Down in Texas, by Killeen, my model predicts that they will have about 500,000 people coming to that one spot alone. So watch out. So now I isolate some of these, what I call drive sheds, by destination states. So these are the destinations for Indiana. So you can see Indiana is going to draw people from South Carolina through North Dakota. Of course, this isn't 100% accurate, but I'm working on averages. On average, most people will drive the shortest path. Some people will go left, some people will go right, but I'm trying to look at the big picture and determine averages. This is the drive sheds for Ohio. And this is where some of you will end up on eclipse day. You'll see Ohio draws a lot of people from Detroit and through most of Michigan. And I also used very detailed census demographic data to compute with pretty high degree of accuracy how many people live inside the path by state. For the entire United States, it's about 31.6 million people. That's almost 10% of the entire country already living inside the path. And of that 31 million people, if you assume 10% will have friends and relatives come to visit for the eclipse, just from that, you've got a big eclipse crowd. Tennessee, just a tiny quarter, has 80 people. This is another view. As I said, 31.6 million people live inside the path. But if you look at this, you'll also see that over half of the United States lives within 250 miles of the eclipse path. That means over half of the US, it's not an unreasonable drive to come to the eclipse. Now, this is what the sky will look like during the eclipse. And these are what's called the Saros cycle. The Saros cycle is a periodicity or a rhythm in eclipse patterns. There is a rhythm to eclipses. You don't see that rhythm at all from one eclipse to the next one, but there is a pattern of 18 years, 11 days, and 8 hours called the Saros, where you see this rhythm. And so they happen to have similar circumstances. The eclipse in this Saros happens to be in the same Saros as the eclipse of 2186. Talk to any serious eclipse geek, and 2186 is on their calendar because it's an exceptionally long eclipse, 7 minutes and 29 seconds. The theoretical longest possible solar eclipse is 7 minutes and 31 seconds. So that's awfully close. This is a view of all the Saros. These are all of the solar eclipses of the 21st century, partials, annulars, totals, all of them. And they're organized by this rhythm called the Saros. And so we're going to slowly zoom in on our eclipse coming up, which is right here. Here it is. This is the 2024 eclipse coming up. The next one in this Saros is 2042 in 18 years, 2060, 2078, and so forth. So this is how all the eclipses are organized. Now we're back to this view. You will definitely see Jupiter, Mercury, and Venus. Saturn and Mars, maybe not. If you really look for them, you may see them. But what I'll be looking for is I'm going to be allocating maybe 10 seconds of the precious 4 minutes with binoculars, and I'm going to look at Jupiter, because within 1 degree of Jupiter, there's going to be a comet. It probably won't be as bright enough to see with your eye, but it'll be visible with binoculars if you know where to look. So I will look, but I will only allocate a small amount of time to that. Now here are some, this is from the annular eclipse last October. And I actually went to this place called the Vista Grande Overlook. For an annular eclipse, I went to the very edge of the eclipse path to see an extended duration of a phenomena called Bailey's heats. And it lasted for over 5 minutes. If you're in the center during an annular eclipse, it only lasts a few seconds. Now here is, I showed this to you before during the animation, but note that the shadow here has these inflection points. And when I first started making these maps, I noticed these straight edges and then these turning points. And I wondered to myself, what does this mean? And in collaboration with a couple of experts, um, we all came to the consensus that each of these straight segments means that you will see one particular Bailey bead as the diamond ring. If you don't know, the diamond ring happens at the very beginning and very end of total solar eclipse. It's one of the peak moments of the eclipse. And it's actually the very last Bailey's bead that is a diamond ring. But something happens interesting here. And after puzzling over it for a while, myself and a couple of colleagues figured it out. We figured out those turning points can predict where you will see a phenomena called the double diamond ring. And that is, instead of Bailey's beads converging to a single, they converge to two separated single beads. You can see these inflection points more clearly in this map. For example, here is one. And then this area very clearly shows that inflection. So if you position yourself here, then you're guaranteed to see a double diamond ring during either the beginning or end of total solar eclipse. So this is the world premiere. These are the first ever maps produced that predict exactly where you will see the double diamond ring, either at the beginning for the green or at the end for the blue. So if you want to see a double diamond ring, this is your guide. The thicker lines are the double diamond rings that I expect to be more prominent. The thin lines, they might be subtle. You might see it in a photograph, but it might not have been so obvious to the eye. But I've produced a series of 15 maps. I haven't published them yet. I'm going to be publishing them in the coming week, so you are the first to see these maps. And I'll say a couple of other things about it too is there's some nice, okay, this is another map showing the area where many of you will be, Wapakoneta, Muncie, and so forth. And one thing I'll say about this is there's some enticing thick lines where you'll see double diamond rings, but if you're on the edge, you'll only get 1 or 2 minutes of totality. So I would advise people to seek, if they want to see a double diamond ring, seek these spots out in the center of the path so you're not sacrificing totality. And here's a close-up of these lines. So sometime next week, if you go to my website, Great American Eclipse, you'll see these new maps prominently published where you can see the double diamond ring. Here's an interesting circumstance. See that blue line right along Lake Erie coastline where Cleveland is? That's going to be an amazing view. Cleveland is close to the center line, so they're going to get a great double diamond ring on top of it. Future eclipses, this is our last section. Now we're going to present some maps from our Atlas of Solar Eclipses. This was a big project that Michael Bakich and I worked on. This book took a year of my life to produce. It was a lot of calculation. And so first of all, for coming eclipses, when was the last eclipse in Michigan? 1954. When will the next one be? 2099. And I did the math. I used my GIS software. This took a lot of work too, but I was able to compute this with the GIS software. The state with, I think Arizona has the longest gap till the next eclipse, which was 2205. And I think Delaware also had 2144. Okay, now this is the very next total solar eclipse. It starts in in Siberia, and then it crosses Greenland, Iceland, and ends at sunset over Spain. It's almost sunset in Spain, and it will end very close to sunset in the Mallorca, the Balearic Islands, in the Mediterranean. So if you get the bug after April 8th, buy a plane ticket for Spain in 2026. This is the detail of the path through Greenland. There's a large fjord down here that my friend Jay Anderson says has a microclimate that may be very favorable on eclipse day. It may be cloudy in the surrounding area, but this particular fjord may very well have clear skies. So there's going to be some ships that go to those locations. I'd like to go there, but I've committed to taking my whole family to Spain. So we're going to find a big house in Spain and just have a big eclipse party there. So here's a little more detail on the next total solar eclipse in Spain. So, and after, even more detail, you can see that since the shadow is at such an oblique angle, it becomes very elongated. That happens at every eclipse. Shadows get long and skinny, both at sunrise when they begin and at sunset when they end. It's not a very long eclipse, but as I said, I travel the world to see a 1-minute eclipse because they're all so remarkable. Now, after 2026, this is a very long duration eclipse in the summer of 2027. You can see it goes over Gibraltar, the far south of Spain, Morocco, Algeria, Libya, and Egypt. I will be right here in Luxor. I've already made my booking for the 2027 eclipse. To see the eclipse from the ancient ruins of Luxor, wow, what an opportunity. So I grabbed that opportunity. So that's only 3 years from now. And again, if you get the eclipse bug, this is a great trip. There's going to be ships in the Mediterranean. Now, when is the next US eclipse? Turns out that a lot of journalists in the eclipse stories recently get it wrong. They think it's 2044 and 2045, but they always forget the 2033 total eclipse that passes over Northwest Alaska. And so that's less than 9 years after the April 8th eclipse. So it's not that long until that eclipse. Now, unfortunately, there aren't very many hotels and places in this path, but the Intrepid will go. I'll certainly go. I haven't made my booking yet, though. That comes later. An interesting fact about the Alaska eclipse is the same corner of Alaska is the only part that doesn't get a partial eclipse in April, and they get a total eclipse in 2033. Now, after this is the second to next eclipse in the US. This is in 2044. It begins in Greenland at sunrise, and it progresses over Canada and ends at sunset over North Dakota and Montana. So it passes over some great spots in Canada as well. And this is the big one. you think this eclipse is going to be long with 4 minutes and 28 seconds? How about 6 minutes and 6 seconds? Because that's a treat that we have coming on August 12th, 2045. And this eclipse passes the US from California to Florida. And you can see the longest duration for this eclipse is going to be just off the coast of Florida. Florida will be a key spot because of the long duration, but also good weather prospects. So in Florida, you've got two great choices for the total solar eclipse. You can, if you're a Disney fan, go to Orlando, go to Disney World. If you're a space nerd, go to Cape Canaveral and watch the eclipse. And I'm not sure yet where I'm going, but, and actually I'll be 89 years old. So I'm trying to live a healthy lifestyle so that I have the longevity to make it to 2045 and hopefully beyond. So these are some of the coming eclipses. Here you'll see Florida, this whole band of Florida gets over 6 minutes of total solar eclipse. That's remarkable. That's a very long eclipse. Like I said earlier, the theoretical maximum is just over 7.5 minutes. And now, these are all the total and annular solar eclipses around the world. Solar eclipses aren't particularly rare. People often say that it's rare. What's rare is not that they happen somewhere in the world. It's rare that they come to you. And there's an eclipse coming very close to you, 100, 150 miles from here. So that's a very rare circumstance. And so, of course, I would urge you all to make the short trip to the eclipse from here. And once you really get the bug, this literally is your vacation planner. I can look at these and I know pretty much where I will be for each of them. And I'd like to now open this up for question and answer. Now, in a few seconds, behind me, there's going to be a video that starts. And this video I took from Chile, from an eclipse in Chile. And so this will show you what changes in the sky brightness. You're not seeing the eclipse itself, but you're seeing the shadow moving over the landscape. And to set some context, this was our location. We were in this location, Vicuña, in a valley with several major observatories on the ridgeline, as you saw before. The eclipse is coming very close now. And this is happening in real time. This is not a time lapse. This is real time. And so while we watch this, and you can continue watching this, it'll be 2 or 3 more minutes. I'm happy to take any of your questions.
All right, thank you, Michael. That's great. Let's give him a round of applause real quick. And I just want to reemphasize before we take questions, you know, maybe some of you members saw me give the eclipse talk back in September at the Nature Center, and I used a few of his maps. But remember, throughout this whole presentation, those maps were his. He made them. So I think that deserves a round of applause right there. It's amazing work. All right, so let's go ahead and take questions. Wait for the microphone so the folks at home can hear you. We maxed out around 164 at home, so that's great. We had a huge crowd here and at home.
Hi, Michael. Welcome to Kalamazoo. You explained, or you showed a slide about the Saros cycles, and I understand that there's a periodicity of 18 years and plus or minus. But what I don't understand is why they're overlapping and not consecutive. Can you explain that a little bit, please?
Okay, that's a great question because I expected that as well. When I made the same diagram for the last eclipse or other eclipses, they were not overlapping, that you saw a neat progression. But then the second one that I showed, which showed the ones from 2024 to 2186, they showed that neat progression without overlaps. And I emailed my friend Fred Espenak and I asked him that exact question. And he gave me a long technical answer, but the answer boiled down to that he said, don't forget that while the latitude shift is more prominent, there's also a longitudinal shift. And I can't recall the explanation well enough, but it has to do with combining those shifts, and Fred had a clear explanation for it. Did I answer your question? No? Okay.
Every year, there's several eclipses, but they're all from different Saros cycles, and I just don't understand how the Saros cycles can be overlapping rather than consecutive.
Oh, okay.
So that was my question.
Yeah, it's the Saros is basically a beat phenomena between three different types of months. There's a lunar month, and then it's called synodic, and I can't remember all the details, but it's a beat phenomena where different types of months repeat a pattern. There's a small coincidence in there.
If you have that email from Espenak, send it to me and I'll make it into a newsletter article.
Okay.
Karen? Karen, huh?
So I really enjoyed your presentation, and I was intrigued by the double diamond map, and I'm not sure I've completely understood it. In order to see the double diamonds, do you have to actually be right on one of those lines, or is it like between the lines?
Close. You would pretty much have to be very close, either on or very close to the line to see the double diamond ring. But I plotted out all of those shapes, and I basically did a connect the dots. I had to do it manually. I tried to find an automated way to do it with the GIS. I just couldn't, so I had to manually do the connect the dots to draw those lines. But it's very clear when you compare those lines to the underlying shapes of the moon's shadows.
Thank you.
You get the lights.
Hi, I'm Jack from Pawpaw. Outstanding presentation. Can you explain what it is about the distance between the moon, the earth, and the sun that varies, that causes these different patterns? Sometimes it's like I would expect, a long, straight one, but sometimes you got a backward C and sometimes you got a inverted C. What's going on between?
Okay, the ones that seem to go backwards are always in the polar regions, or part of it is in the polar region. Has to be in the polar region because for an eclipse to go east to west instead of west to east, the normal eclipse path is west to east. But at very high latitudes, if the Earth is tilted towards the sun a bit, which can be tilted up to 23.5 degrees, depending on the season, then the shadow can actually go above the North Pole and hit the Earth above the North Pole and then curve around. And that's why you see the backwards and those C shapes. They all happen at a high latitude. The other major factor is the time of year. So that heavily influences the shape, because typically it's a boomerang shape. So there's several factors, but it depends. The main factor is where the shadow hits the Earth at a high latitude or equatorial region.
Well, thank you for coming to Kalamazoo and thank you for your good work. It's wonderful. My wife and I planned to go what we thought was the obscure little town of Mentor, Ohio, and we were not a question, just a comment. We're surprised to see you actually had it listed on one of your maps. So good job.
Thank you. Yeah, I'd like to say a little bit about how an eclipse chaser thinks. And obviously, the most important consideration is weather. Okay, that's by far the most important consideration. But after weather, then it's mobility. What are your mobility options? And I personally chose Fredericksburg, Texas, because it's got reasonably good weather prospects and it's very close to the center line. But if you look at a road map of Texas, Fredericksburg has 6 highways radiating out. That means on eclipse morning, if I have patchy clouds in Fredericksburg, I've got 6 ways to go. So when an eclipse chaser, a serious eclipse chaser chooses a location, not only do you choose for weather and duration, but you also choose for mobility. I did the same thing in 2017. I chose Castro, Wyoming, because Interstate 80 had a long section that was close to the center line, and Castro was right in the middle of that long section. So I had that mobility option.
So I really appreciate your presentation, but I have to ask one thing. For those of us who are hoping that we live to be 144 years old, to see the 2099 solar eclipse over Southwest Michigan, when are you going to publish that map? I want to know. Medical science is on its way.
Over my dead body. No, I haven't published anything detailed that far out. I published very detailed maps out to 2045. I'll probably do more. After April, I run the website called Great American Eclipse. I know things are going to quiet down and kind of slow down after the eclipse. And I'm thinking of shifting my focus from America to more of a global thing, because there isn't going to be one in the US for quite a while. So I'll keep active, but it began for me, it began as a hobby, and then my wife helped turn it into a business. She runs the business side of it. And now I'd like to take it back to just being a hobby.
Thank you so much. Early on in your presentation, you mentioned about the speed of the shadow moving and the geometry involved. Can you explain a little bit more of that again?
There's actually a really interesting fact about that that I'll get to. But first of all, so your question is, why does the speed increase? Well, a total solar eclipse, the shadow is slowest when it is at the point of greatest eclipse, the center point of the eclipse. And it has to do with thinking about how shadows get projected. at the midpoint of the eclipse, the shadow to the Earth's surface. Okay. And then as the shadow progresses, it wraps around the Earth. And because of the curvature of the Earth, you have an oblique angle. Well, that oblique angle not only makes a shadow longer, but it makes a shadow faster. Okay, but now here's the really interesting, mind-blowing fact that even some people who are experts don't understand this. But I'll say this. For an extremely brief moment in time, the speed of the Earth's shadow at sunset, at the moment the shadow lifts off the Earth and is at the very edge of the Earth, for an extremely brief moment, the speed of the shadow is faster than the speed of light. It's superluminal. And how can that be? And that trips up a lot of people. It's because a shadow is not a physical thing. It's a projection. A projection can move faster than the speed of light. You can shine a laser pointer at night from one galaxy to the next, and that projection is moving much, much faster than the speed of light, but it's just a projection. Shadows are the same. So for a very brief moment, it's superluminal, faster than the speed of light. But that moment is extremely short. A friend of mine actually calculated it. It's a small fraction of a second.
We will try to get to some questions on Zoom, by the way, so we'll do the best we can. But we do have a lot of people that actually came to the meeting. So.
Pity.
Thank you so much, Michael. This is wonderful. So I caught the eclipse bug a few years ago in 2017. Luck smiled on me that day. I was just in a friend's backyard in Kentucky because she was in the path of totality, and weather happened to be perfect. You mentioned that you've chosen a location based on mobility, because clearly you know the value of getting out of the way of clouds. Mm-hmm. Have you, as an eclipse chaser, ever been struck with clouds at that most inopportune time, and what did that feel like, and how did you recover?
Great question. I've seen 11 total solar eclipses and 4 annular eclipses. And I've only been clouded once, and it was for an annular eclipse, my first annular eclipse, and that's a pity. I'll explain to you why. But of the 11 total solar eclipses I've seen, and I have a perfect record, 3 of them I had to take evasive action. Okay. I drove in 1999. I drove from Germany down into Austria because the weather was rotten on eclipse day in 1999, and I drove far enough, and it worked out for me. And it also happened a couple of other in Australia. I had to drive a couple of hours inland to evade the coastal clouds on eclipse morning. So 3 times I took evasive action, and 3 times it worked. But now I'll come back to that first annular that I missed, and that actually was a heartbreaker. Okay, now a total solar eclipse is far more dramatic than an annular eclipse, except there's one type of annular eclipse that's very, very dramatic to see. Not quite a total, but it's worth seeing. And that's annular eclipse exactly at sunset or sunrise. And what's so special about seeing an annular eclipse at sunset or sunrise is 2 things. One is that you're looking through some heavy atmosphere with a lot of refraction, and refraction of different levels. So you'll see this amazing squashed ring. So that's one thing that you'll see. And then the other advantage of a sunset or sunrise is if you're where the atmosphere is heavy enough, you can look directly at it without any filters. Okay. And that's a circumstance I had for my very first annular eclipse on January 4th, 1992. I was on Catalina Island, where the eclipse was supposed to be maximum at sunset, and I got clouded. So, at someday I will find another annular eclipse that I can see at sunset or sunrise. I've got a few ideas.
All right, let's go ahead and get one from home. So, Greg, why don't you go ahead and ask your question from home?
Okay. Excellent presentation, by the way. I've actually an eclipse chaser. I've been on a 13 total and 3 annular, and I have a 77% success rate for the totals and 100% for the annulars. And I saw both transits of Venus from beginning to end. And my question is just a comment. You mentioned for Florida, you know, the August 2045 eclipse. I reside in Florida on the Gulf Coast, and I've been here since 1990. And August and September are the worst months in Florida because it's hurricane season. And as a matter of fact, the August eclipse in 2017. 1 week later, we got hit by a Category 5 Hurricane Irma. Luckily, it was Category 2 by the time it hit us. It went right through the middle of the state. There was absolutely nowhere to hide. And then if the hurricanes aside, what happens in the morning, it starts out clear and the clouds start building. And then by noontime, it's either totally overcast or it's raining out. And then it starts clearing in the evening again. So it's very, very iffy. If you know, I wouldn't recommend to come to Florida, you know, due to the weather for the August eclipse. Yeah, it'll pass right through the Disney parks, which is amazing. That's going to be great PR for Disney and Universal. But that's just, you know, from my experience living here 30 years. Yeah.
Your comment brings up another related interesting point of a circumstance for this April eclipse. I didn't show it in my presentation, but I made a map that showed all the tornado tracks in April, and it showed the path of the eclipse. And there's a very strong correlation between the two. So some people are going to have fun chasing a tornado and an eclipse on the same day. I'm sure someone will do it.
Tornado tracks on April 8th or tornado tracks all spring?
Actually, April 8th.
Oh.
Well, no, what I did was I took the data from a couple days before and a couple days after, so I would have enough data. Yeah.
Do not observe the eclipse from a trailer park on April 8th. You're a goner. We have one more question here. No. Okay. I did see some nice technical questions on Zoom, but I'm going to encourage those people to join us next month for the general meeting, because we will have none other than Mr. Eclipse himself, Fred Espinack, via Zoom, because he didn't want to come to Kalamazoo. He's afraid to get COVID and miss the eclipse. That's how obsessed he is. He doesn't want to take any chances. So just want to, again, thank you to Michael Zeiler for coming all the way from Santa Fe. So thank you very much. And again, because Jay Anderson last month got snowed in, or we had to kind of cancel on him because things were canceled here. Again, Michael is our only live speaker in the entire series. So we really, really appreciate him coming here.